This is 8.4, multiplying and dividing rational expressions. Vocabulary, simplified form of a rational expression. It is an expression in which its numerator and denominator have no common factors. So, how do we simplify a rational expression? What we can do is we just divide out the common factors. So over here, let's write some examples. If we have 3x over 4x, we can mark out the x part, and that will reduce to 3 over 4. Okay, one thing to be careful of is we cannot mark out parts of addition or subtraction problem, even though the parts may be the same. So I cannot mark out the x's here because they are part of the addition or subtraction. But if we had two terms up here and another one was 4 plus x, these are multiplied to each other. And when they're multiplied, I can cross them out. Okay, so simplifying rational expressions. Example 1. Make this a little bigger. All right, I have x's on top, x's on bottom. Can I mark those out? No, because I have addition signs with them. So I need to factor them out. Go back to your rules for factoring quadratics and put those in our two parentheses. So that is, let me see if I can make that a little bit better. Oop. Okay. So x plus 5 x plus 2. Okay, on bottom, that's the difference between two squares. So that would be x plus 4, no, plus 2, x minus 2. Okay, do we have a factor that's same on the top and the bottom? Yes, the x plus 2, so I can cross those out, and I'm left with x plus 5 over x minus 2 as my final answer. Okay, so x plus 5 over x minus 2. Again, if you were doing this on a test, you want to make sure you're right, choose any number such as 2 for x, put it in this equation, get a decimal answer for your number, and then actually x can't be 2 this time, so let's throw a 3 in there and then see if you get the same answer here. Okay, how do we multiply these? Just like any normal multiplication for fractions. So you multiply the numerators and multiply the denominators. Write the new fraction in simplified form. So it's AC over BD. And then we simplify it if possible. Example 2. We are going to multiply these out. Now, there is, instead of just multiplying across, if we put them in simplified form and factor them, it'll be a lot faster to multiply them. So the top of this fraction, do you see that 2x is a common factor? We can... Okay, example 3. Multiply a rational expression by a polynomial. Remember, a rational expression is a fraction with x on the bottom. A polynomial is a group of terms of x, so I need this group to be a fraction. So all I have to do for that is to place it over 1. Just the way when you were in 4th grade and you were learning how to make 4 into a fraction, you learned that if you just put it over 1, you didn't change the value of it. Now I need to factor the numerator and the denominator. X minus 4, can't do anything with that. Let's look at this x squared minus x plus 1. Okay, you would be tempted to say that's x, okay, plus, with a minus here, the only way you can do that is x minus something times x minus something. But if I stick a 1 in here, does that FOIL back to this? No, because I would have x squared minus 2x plus 1. So this cannot be factored out. So I have to leave it just the way it is. You would have irrational numbers if you tried to factor that out. If you don't know, try the quadratic formula, and if you get an irrational number, or imaginary number, you can just go back to the unfactored form. Okay, on the bottom, x cubed plus 1. Well, that's a difference between two cubes, and we had the pattern for that was a, so a was x, plus b, b is 1, and then we turned this into a polynomial, that was a squared, so x squared, minus a times b, so 1 times x is x, and then plus b squared. If you forget how to do this, it's up on the wall on a poster. So, that's my two factors. Notice that the top and the bottom factors are the same, so I can mark those out. I'm left with x minus 4 over x plus 1. Okay, dividing rational expressions. Do you remember how you learned to divide fractions? Let's say that you had 1/2 divided by 2. We had you make that into fraction, and then we told you to flip the second one and multiply. Okay, we're going to do the same thing with rational expressions. So we can just flip it over and multiply. So we'll have AD over BC, and simplify it if it's possible. So down here at the bottom, example 4, divide this rational expression. We are going to flip the second one over to get x squared plus 6x minus 7, 8x squared minus 8x. We're going to factor it out. I could pull an 8 out, x, sorry, that's the bottom. So I can say x minus 7 plus 1. On the bottom, I can pull out an 8x, and I'm left with x minus 1. Now, I think I got the top wrong. I did. Usually, remember I told you that they want the top and the bottom to be the same factor, so you can mark some off. What do I have here? I don't have the top and the bottom, so I'm going to go back and look at this. Does this FOIL back to becoming plus 6? No. I need to switch these signs, don't I? It's minus 1. After I switch the signs, I can mark out that one and this one. I can mark out that and this. And I'm left with 3 over 8x. Okay, checkpoint. Multiply or divide. draw it over 1, factor it out, 2x squared, difference between two cubes, so a minus b, 27, what's the cube root of 27? It's 3, times a squared, so x squared. This changes into a plus ab, so 3x, and then a plus b squared, so 9, and then times x squared plus 3x plus 9. Oh, isn't that nice? I can mark those out. Okay, and leaving me with negative 2x squared over x minus 3. Okay, number 4. I am going to go ahead and factor this bottom while I'm here. So 9x, x minus 2, and then flip the top, factor out this while I flip it, so 2x, and then x. Only way to get a minus and a plus is to have two minus signs. If I have, only way to get 2 would be 1 and 1. Let's check that and make sure. Gosh, no, that's not right. So the other way to get 2 is minus 2 and 1. Oh, I was multiplying or adding instead of multiplying. So this is right. Minus 4 minus 1 is minus 5x. Okay, on the bottom, 2x, and then I want 5 here, x is here, and then plus, no, minus 1, minus 5. Okay, let's mark out what we can. I have 2x minus 1, 2x minus 1, x minus 2, x minus 2, x minus 5, x minus 5. What am I left with? Nothing on top, so that means it's a 1 over 9x.